Section 7.2 has to do with the Pythagorean theorem and its converse. You're already real familiar with the Pythagorean theorem. It says that if you have a right triangle and you take the one leg and you square it and you add it to the other leg and you square it, it's going to equal the hypotenuse squared. Now remember, the hypotenuse is always the side across from the right angle. So a squared plus b squared is equal to c squared. So a couple examples here. Notice that I do not have this side. I'll call it a. So a squared plus 7 squared, because here's your right angle, so those are the two legs, is going to equal 14 squared. If I go ahead and solve for that, it's 14 squared minus 7 squared, or a squared is equal to 147, and then you would take the square root of 147, and again you can give me a decimal value or you could just break it down. So it's 12.12 rounded off. So A would give me that measurement, so that would be the measurement of the side of that triangle. Here's another one. Here's your right angle. So I would have 3 squared plus d squared is equal to 6 squared. D squared is going to equal 6 squared minus 3 squared. So you have 36 minus 9, which is going to give me a 27. So d squared is equal to 27, so I would need to go the square root of 27 is going to give me d being equal to 5.20. Okay, you've been working with the Pythagorean theorem for a while, so hopefully this isn't a problem. The converse of it says, if you have a rectangle and you can take the x and square it and the y and square it, because those are the two legs, and get the z squared, then I know for sure that that is a right triangle. So if the measurements fit in those locations and it makes it true, then I can conclude that that is a right triangle. So as long as the measurements work in the Pythagorean theorem, you're good. A lot of times they use a coordinate plane with this particular theorem, and basically it's saying, look at this triangle and verify that this is a right triangle. So basically what I would have to do is I would have to find the distance here. Now I will say you're rounding, so sometimes this is a little off. So I want to find the distance from Q to P, from P to R, and then from Q to R. And you can see that the Q to R should be the hypotenuse here. So I'm going to use the distance formula on my calculator. And I'm going to plug in, I'm going to plug in the Q to P. So I've got a -3, 6, and I've got a 3, 2, and that's going to give me approximately, and it's rounded, 7.21. And then I'm going to go P to R. So I've got 5, 5, and I have 3, 2. And that's going to give me approximately 3.61. And then I'm going to do Q to R, so I have -3, 6, and I have 5, 5, and that's going to give me approximately 8.06. So for it to work, now remember this is rounded, so they might be a little off. The alternate way to do it, to have it not be a little off, is to not use your program on your calculator, and you probably don't want to do that. 7.21 squared plus 3.61 squared is going to give me approximately 650.0162. I'm going to square this other side, and I'm going to get 64.9636. Well, you can see that this would round off to 65, so there's very little difference between these two. So I would say yes, this is a right triangle. Like I said, the only way to keep it and make it exact is if you go ahead and do it by hand and you leave it underneath the square root. All right, a Pythagorean triplet is 3 whole numbers that satisfy the Pythagorean equation. The key is that it has to be whole numbers and it has to satisfy the Pythagorean equation. So then it asks you, are these Pythagorean triplets? So the larger number is always going to be your hypotenuse. So you would have 8 squared plus 15 squared is equal to 16 squared. So if I take my calculator, 8 squared plus 15 squared is going to give me 289. 16 squared is equal to 256. So therefore, this would be no. They are whole numbers, but they do not work in the Pythagorean equation. Let's do this one. So I would have 20 squared plus 48 squared equals 52 squared. So this is going to be 2,704 on this side, and this is going to be 2,704 on this side. So this is a yes. Those two numbers represent a Pythagorean triplet. They not only work in the Pythagorean equation, but they're also whole numbers. Now, I can tell you right now that this is no, because these are not whole numbers. But if I were to do this out, this is your larger number. So I'm going to show you, we're going to go ahead and see if it could be a right triangle. So it can be a right triangle and still not be a Pythagorean triplet. To be a right triangle, it just has to work in the Pythagorean theorem. To be a right triplet, it has to be whole numbers and work in the Pythagorean theorem. So when I square this, I'm going to get 3 over 25. When I square this, I'm going to get 6 over 25. And when I square this, I'm going to get 9 over 25. So 9 over 25 is going to equal 9 over 25. So this is a right triangle, but it is not a Pythagorean triplet because these are not whole numbers. So even though it works in the Pythagorean theorem, it's not a Pythagorean triplet. All right, your homework on this is page 354, 12 through 28 even.